Hi everyone, so today we're going to be doing notes on sections 2.2, 2.3, and 2.4, which is all about graphing and writing linear equations. I'm combining all of these sections together because this should all still be review for you, so we're going to go through it relatively quickly, but you'll still get a good amount of information in the examples that I give. So, first thing I want to talk about, oh, whoops, I forgot. Pause this and write this down. Okay, so first thing I want to talk about is the definition of the rate of change. So rate of change is basically just how much y changes in relation to x. This is more commonly known as the slope, which is probably how you know it, and the slope is known as rise over run. So let's look specifically at what this slope formula is. So if you're given two coordinate points, now I put these little teeny tiny numbers to make them x sub 1 and and y sub 1, x sub 2 and y sub 2, so that you can tell my first point apart from my second point. Then when we plug this into the equation for slope, it's y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. Now some of you may wonder if you can switch the 1's and the 2's around. Yes, you absolutely can, as long as you keep it the same. So see here where it's the second number and then the first one, as long as you keep the 1's and the 2's lined up. So you could do y sub 1 minus y sub 2 over x sub 1 minus x sub 2, just as long as you're consistent on the top and bottom. And how you've seen this more commonly when you're looking at a graph is rise over run. So rise is when you're going up or down, positive or negative. I'll add that little note on there. Up is positive, down is negative. And then the run is right and left, where right is positive, left is negative. All right, let's go ahead and look at our first example. So we want to find the slope between these 2 points. Now, for the sake of keeping track of what's what, I'm going to go ahead and label these with the x sub 1, y sub 1, x sub 2, y sub 2. Just so I keep track when I'm writing them into my formula. If you can do it without writing those little notations, totally fine. All right, so my slope is equal to y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. Now notice we are subtracting a negative. You can either put it in parentheses or you can just do another minus. I like to do the parentheses so that I make sure I see it and I don't miss that double negative. Now I'm just going to simplify. So negative 5 over, now this becomes negative 1 plus 4, which will be 3. So there's our answer. And I just realized, sorry if my voice sounds a little scratchy. All of this smoky weather and stuff and the bad air quality, it's been really bothering my sinuses and my allergies, so that's why my voice sounds really scratchy. All right, let's move on to looking at slope-intercept form. So this is something that you should be really familiar with. This is basically just the standard way of graphing a line, the y equals mx plus b. And in this, the m is the slope, and the b is the y-intercept, which is the point 0, b. So let's go ahead and look at an example of graphing this. So we want to graph y equals negative 2/3 x plus 1. So if I'm looking at this, my slope is negative 2/3, and my y-intercept is 0, 1. That's my y-intercept. So your process for graphing these, scoot that down a little bit. Your process for graphing these is to, number one, plot the y-intercept. And then step 2 is to use the slope to get more points. Now, because my slope is a negative number, I can either look at this as -2/3, where I would be going down and to the right, or I can look at it as 2/-3, where I'm going up and to the left. No matter which one you use, you're going to get the exact same line. It's just going to be having you count your points in different directions when you actually graph it. So this piece of graph paper, I attached to your notes PDF with a bunch of little blank graphs on it. So you can either print that out, or if you have your own graph paper, use that. Or if you like to be brave and just hand draw a graph on lined paper or whatever paper you're using. I personally don't do that because I'm horrible at drawing straight lines. So I print out these handy, nifty little graphs. If you are printing this out, or even if you're not, make sure you label your X and Y axis. And then I just tape this onto my paper already. So let's go ahead and plot the y-intercept at 0, 1. And I'm just going to assume that each of these little boxes goes by 1. So I plot my y-intercept, and then I can either go down and to the right, so down 2 to the right 3, and I could do that again, down 2 to the right 3, or I could have gone up 2 to the left 3, up 2 to the left 3. Now, I like to say, for a good rule of thumb, for graphing straight lines, do at least 3 points, because it helps you make it more accurate. So say, for example, let's say I just did this pink point and that blue point. When I draw those together, depending on how I place my ruler, my line could be a little wonky. It could be a little off, depending on how nicely I drew my little points. It could be a little crooked. So I draw more so that I can make sure this line is super accurate. I'll do this in black. Connect my points. Draw the little arrows on the end because this line goes on forever. And there we go. My awesome alligator ruler. Let's move on to another example. Now I'm going to graph one, but this one is not in that super nice y = mx + b form. So what I need to do is get it in that correct form first. So I need to get the y by itself. So I'm going to add 5x to both sides. So I get 2y = 5x + 6. And then divide both sides by 2. But I need to divide everything over here by 2. Not just the 5x, not just the 6. All of it. So y = 5/2. I can leave it like that or do a decimal. I'm going to leave it as a fraction so it's easy to count rise over run. And then 6/2 is just 3. All right, so now that I have it in this form, what's my slope? I should have asked that before I drew an arrow pointing to it. My slope is 5/2. And what's my y-intercept? Good, everyone should have said 3. or the point 0, comma 3. All right, so for this one, since the slope is positive, that means 5 over 2, I can either go up and to the right, or this is like saying negative 5 over negative 2. Because remember, a negative divided by a negative is still a positive. So that would be down and to the left. So we have two options for drawing this. So I get my little graph paper. I'm going to label my x and y axis and then plot the points. I want you to go ahead and try plotting these on your own. All right, so for this one, I went ahead and graphed it. Now, it's a good thing I looked at the down and to the left, because on my graph that I had printed out, going up 5, I would have run out of room. I would have been off the graph. So instead, I went down and to the left, down and to the left to get my 3 points. Let's do another example. All right, next example. Now that we've done a couple of graphs, now we're going to get into actually writing these equations. So if you are given this table, you need to write an equation by using these values. So go ahead and take a second to pause this and write this down. So the two things that I need to be able to write my equation are the slope and the y-intercept. So step 1, find the slope. Okay, so looking at this as in a table, remember slope is the change in y divided by the change in x. So my x values and my y values. Let's look at how the y values change. From negative 3 to negative 1, I add 2. From negative 1 to 3, I add 4. So it's not consistent, but let's see what the other side is. From negative 5 to negative 4, we add 1. And then from negative 4 to negative 2, we add 2. So they both change. So if we look at the change in y divided by the change in x, it is 2 divided by 1, which is 2, or 4 divided by 2, which is 2. My slope should be 2. So you can either do it that way, or you can use the equation, the y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So I showed you how to do it using the table, but let's also use the equation just to double check. So I'm going to use any points here that I want. I could use the first 2, I could use the last 2, I could use 2 random ones. It's up to you. I personally like using 0 whenever I possibly can, so I'm going to use the bottom 2 points, the negative 1, comma 5 and 0, comma 7. I'm going to pick this as my first point and this as my second point, just because it's written in order top to bottom, 1 to 2. So this is going to be 7 minus 5 divided by 0 minus negative 1, which is 2 over 1, which is 2, which is exactly what we found by looking at this. Our little arrows to see how it changes. So we're halfway there. Step 2, find the y-intercept. Now remember, this is when x equals 0, which is super convenient because it's given to us in the equation. We didn't have to do a thing. So my y-intercept is 0, comma 7. Super nice. So the last thing I need to do is just write my equation using my slope and y-intercept. So y equals 2x plus 7. Just plug them in. And we're done. Easy peasy. I don't know why I just said that. I don't think I've ever said that expression in my life. I've heard it before. Easy peasy lemon squeezy. It's hard to say. I don't know. I think that's like a really old-fashioned saying. Anyways, let's move on. Next example, now we want to write the equation of a line where we're given a point that it passes through and the slope. So realistically, if you wanted to, you could take out a graph, plot this point, and then count your slope until you get a y-intercept and see what it is. But I'm going to show you another way to do it as well. So there's this formula called point slope form, which is honestly really helpful, especially for things like this. So point slope form. This is the equation. Y minus y sub 1 equals m times x minus x sub 1. Now the reason why this is helpful is because this formula uses m, the slope, which we have, and a coordinate point, x sub 1 comma y sub 1. We have a coordinate point. That's why this is really helpful. Okay, so I'm going to label this x sub 1, y sub 1. Ouch. And then we know 4/3 is my slope. So I'm going to go ahead and plug in this information. So y minus y sub 1, which is 3, equals m, which is 4/3, times x minus x sub 1, which is -2. So remember, minus -2. This minus is part of the equation. It has to stay there. All right, let's go ahead and simplify now. So y minus 3 equals 4/3 x plus 2. Now I need to make this in the form y equals mx plus b, which means I need to take care of this stuff over here and get rid of those parentheses. So what do you think I do next? Good. We are going to distribute that 4/3. So y minus 3 equals 4/3 x. 4/3 times 2 becomes 8/3. If you have questions about how I got that, let me know when we come back to class. Now I need to add 3 to both sides. Oh, I just realized I forgot to draw the little distributing rainbow. There we go. So add 3 to both sides. So y equals 4/3 x. But now I need to somehow put together this 8/3 and 3. So I'm just going to do a little side note over here. Not really on the side, kind of on the bottom, whatever, bottom note. So 8/3 plus 3, but I need to make this so that it's a fraction over 3. So I have to multiply top and bottom. This is like saying 3/1. I need to multiply top and bottom by 3. So instead of saying I'm adding 3, I'm adding 9/3, which is still 3. So this gives me 17/3. There's my answer. But if you don't like the point slope form, or if you just don't remember it, you can still do this using the y equals mx plus b. But you have to use your points, or use your point and your slope to find the y-intercept. So I'm going to plug in 3 for y equals 4/3, that's my slope, times -2 for x plus b. Go ahead and finish solving that for b. All right, so everyone should have finished solving for b. You multiply the 4/3 times -2, and then you add 8/3 to both sides. And again, I showed my work over here with adding those things as fractions, and I got that my y-intercept was 17/3. Now I have my y-intercept, I already had my slope, so I just have to write them in the equation. last example of the day, we are going to do one more problem on finding the equation, writing the equation, I should say. But now we're given 2 points. That's all we have to work with. So what this means is I am going to have to use that formula for slope. The only other option would again be to graph these 2 points, then count the rise over run on the graph to figure out what your slope is, which yes, you can absolutely do that, but it's going to take a lot longer. And if you're not given a graph to already draw it on, you have a chance that you might mess up counting or plotting the points. All right, so I'm going to go ahead and label these x sub 1, y sub 1, x sub 2, y sub 2. Could I have switched these instead and made this the x1, y1, and this one the x2, y2? Yep, absolutely. That is your decision. Just as long as you're consistent with keeping them lined up when you do the slope. All right, so let's go ahead and first find the slope. So m equals, I'll write out the equation one more time for you. And I want you now to go ahead and find it on your own. So pause this. So plugging in the numbers, the x's and y's, you should have gotten that your slope was 2. If you switched your points, the 1's and 2's, you should still get the same answer. Step 2, find the y-intercept. So we have our equation. Y equals mx plus b. Now what we need to do is like what we did with the last example where we plugged in the point and the slope to find our y-intercept, but we're given 2 points instead of 1. Does it matter which point I choose to plug in? Good, you should have answered no. So let me put a little note. Choose either point to plug in to solve for B. Either point. Does not matter which one. Myself personally, I prefer to use the ones that are positive numbers. So I'm going to use the 3, 6. So if I'm using that, my y is 6 equals, my slope is 2, my x is 3 plus b. So 6 equals 6 plus b. If I subtract 6 from both sides, I get 0 equals b. So all that and my y-intercept is 0. So my final step is now to just write my equation. So you have 2 options. You can either write it as y equals 2x plus 0 if you really want that reinforcement that your y-intercept is 0. I will never write it like this. Most people prefer to just write it like that. Both options are still technically correct. This is considered the proper way of writing it. But if you do this, you will not be marked down. I will not take off points or anything like that for writing it like that. Whew. All right, I know that was a lot. I know these notes were long. A lot of this was review though. I think the only thing that may have been a little bit more new and maybe confusing was writing the equations based on what information you were given. But with that said, this is the end of our notes, and have a good rest of your day.